Hey guys, hello and welcome. And I have this book, Wearing a House, the fourth edition. So, for prose by prose, and this book is completely describe how to do wearings. And basically, this book is meant for US. 120 is Americans, right? So, 120 volt, their standards. Basically, they follow the US government's national codes. So but don't worry, the basics is same. So we'll discuss about house wearing, how they do the wearings, and in these books I'll there are many good concepts is there which will surely help you to understand how wearing actually work. So the contents, let's first know the contents. What are the contents they're gonna talk about? First, they will tell about the basic electricity, how electric flow, a residential electrical system, and then wear gauge, what are the wear required for the wear we use, what are the kind of wear they use, and then conduit systems, okay, how to lay down conduits and all. Then we have tools and trades. What are the tools? Specific tools is required for general tools and the AC power tools, some cordless battery tools, and specialized tools. Then we have the service entrances like buried or aerial service, calculating amps, choosing cable, and locating the meter base, buried service entrance, aerial service entrance, and connecting meter base to panel. Then we have, then they talk about, in the fourth chapter we will talk about panel and sub panels. So so we will go in our overview over and over, because this is a 300 page book, so it's not possible to go every page by page. Okay, I mean 150 pages book is there. No, it's more than 150, you see, 300 pages books. So we'll go the important stuff and the basics overview of this book especially. So, and for more details you go and download that book on the internet, is there, it's available on internet, so you will understand more better. Now we'll go over, we'll do the overview on the surface layer, not in detail, but yeah, I'll explain you the concepts more detail. Now plain panel and sub panels, like elements of the main panels, picking panels, what are the size, how to mount a panel and bring cables into the panel, from sub panels to balancing the load, how to do the load balancing also. The art of grounding, then we will talk about the grounding, like how to do grounding and bounding, what is the grounding and bounding system, protections through grounding, and choosing grounding meters, a low resistance panel to earth ground, what needs, why we need grounding, and what is the importance of grounding. Then we will talk about the wiring room by room, so every room how we should do wiring, how to pull the cable in a new construction routing wire, or in a renovation work, okay, outlet boxes design, locations, and many more. Okay, so that's going to be quite interesting. Now in the seventh chapter we will talk about a fuse circuit breakers. Then we have a ground fault interrupters, arc fault interrupters, circuit interrupter, receptacle and boxes, that power socket, then switches, then wiring fixtures, and the light fixtures, okay, the outdoor light fixture, receipt light fixture, or smoke detector, track light, fluorescent light, incandescent light, and the right box for the lights. Then we have wiring appliances like kitchen appliances, baseboard heater, electric wall heater, utility room appliances, submersibles pump, uh, whirlpool tubs and spas, lightning and sugar protection and surge protection, induce voltage utility and in-house surge creator phone and coaxial cable protections, and protecting pump, standby generator, history of incorrect connections, transfer switch style from generator to switch, and picking generators, automatic generators. So there is nothing much technical. This book is more about for electricians and the basics for electrical engineers who are in the supervisor positions. So this will give you an overall idea of how to do electrical wiring, and yeah, basically this deal with that, right, your basics house wiring, residential project. If you are in any residential project, this will help you, this book will surely help you, and you can try this. My recommendation is there, but this book standards is basically in America, they follow the standards, otherwise it's quite okay. So let's start with some of the I'll not go through in deeper, I'll go in the some surface layer. The basics, let's start with the basics. The basics now is very much important, so let's read it. Okay, so not knowing the basics of electricity can get you into a lot of trouble, painful trouble. I remember when my uncle Birds, no need to go with the story. Okay, you need to know the story, you need to know the how electricity flow. So where work much like a garden house, but instead of conveying water, it's convey electricity from one location to another. When you turn on a hose fute, water enter from the spigot push spigot push on a water already in that house, which pushes water out and the end. Basically current also flow like a water. Okay, water is flow from top to bottom, right? From top to water flow in the bottom. Electricity flows same way, the from high voltage to low voltage. Okay, the high voltage is always coming from the generator that in your utility pole that have a 230 volt, and your neutral have a 0 volt. So basically a phase is come and the neutral they close it. So this is inter part, this is the going back part, and this is the way it's complete the circuits and electricity start flow, and in that middle we use our circuit, we add our devices which start consuming the electricity. Okay, now basics, yeah, basics is there, there is nothing to worry. Resistance, we need to know few things like the current the flow of the flow of electron is called current. Like in a wire, in a copper wire, if you see this is a copper wire. Okay, and every seconds, okay, every seconds 6.68 into 10 to the power 18 into 10 to the power 18. Okay, 10 to the power 18 number of electron is flowing. So this is a huge number of electrons is flowing from this one unit of metal. Okay, in a 1 second, in a unit second. So but it should continuously flow, should flow. So that is what the flow of current, this is called current. This flow of electron is called current. And with the both the water, why it's flowing? Because the supply, for example, this is your voltage source. Okay, that your utility pole line. So this is coming from this have a 230 volt or 120 volt, and your neutral point is there, this is a 0 volt. So this is the potential difference is there now. So the current will start flow from high voltage to low voltage. Okay, that is what, but don't do like this, it will be shorted and a huge amount of current will start flowing that electron, and it will burn or make a short circuit. So what we do, we use a devices add there, right? So that consume and rest is back. Okay, so current, and then the resistance is actually the where have some resistive properties, depends on the temperature and the material, and the material and the temperature that reduce that try to stop the smooth flow of electrons. Okay, electrons are rushing from this wire so fast. Okay, so but you know the resistor is that concept that that stopping flowing the flowing of electrons, that is called our resistance. We deny r. The Ohm's law says like voltage is proportional to current, but and there is a there is one unit is there is equals to v is the r. Voltage is depend on the resistance. So that is what, like the voltage is sum of nothing but the resistance and current. V if V increase, I also increase, Okay, it's proportional, but one constant is there, the resistance. Okay, so elements of electricity, here is a resistance is there, the current is there, and what, voltage, electrical pressure is nothing but a voltage. Like if you put your water in a top floor, in your terrace, right, the water tank, so that have a pressure, the weight itself, the gravity try to pull down the water, so it flows through your pipe, right, and you use it. So that is what the same concepts, electricity, all the voltage also push, is there is no gravity is there, so voltage is the call, the potential differences that push the electricity to flow. Okay, now we talk about both three elements, voltage, current, and electricity. And the water analogy can be used to describe to other elements of electricity. To get water to flow, we need water pressure. To get electricity to flow, we need electrical pressure. Electrical pressure or voltage can be provided from either an electrical utility or battery, and just as generated water pressure means more water flow, so higher voltage provide greater electrical flow. This is flow is called the current. With both the water and electricity, diameter of the those hose or wire, so the pipe where or limits the what you get out from it, right. So it is a given amount of time. This flow restrictions is referred to as a resistance. So there is no rocket science, you get it, right. The more the bigger the pipe, it will more amount of water will flow, you will get. So same way, more bigger the wire size, it have the potential to flow more current. Now, element of electricity, elements of electricity is the organized flow of electrons, as I said, along with a conductor. It's generated through heat, pressure, friction, light, chemical actions, and magnetisms. Electricity is a complicated phenomena but is an everyday understanding, and it's helpful to know the meaning of those for them. So voltage, current, resistance, and power, that is what watt is nothing but power is voltage and multiplication of current. Okay, or you can say P equals to V is nothing but I R into I again, right. So I square, current square into resistance. Okay, okay, and this is our in a current representation. And P equals to V, V equals to I square R, right. P equals to I square R, right, that's what. mm. Okay, later we'll tell this. So the watt is this, right. Now, current, resistance, and power, watt, their relationships to each other. Ohm's law, the basic principle of electricity, state that voltage is directly proportional, V is directly proportional to current, and resistance, current and resistance, okay, as well as V proportional to resistance also. You can calculate any of the value if other are two known. So E or V, anything, is the voltage, and I is the current, R is the resistance. So voltage is electrical pressure provided by a battery or other power sources. The higher the voltage, the more the current the source can produce. High voltage is measured by in volts, and voltage quantity is always flow by capacity of watt. So volts, okay, the capital V, so it denoted by V. Voltage between 2 points on a circuit, if the current and the resistance are known, it can calculate it using Ohm's law. All electrical current originally originated from the form and come back to three side terminal of the utility transformer. But this is a transformer, this is a statics device, we will tell you more about this, so don't worry. Now here is how electrical is flowing from wall to wall, from your building, in your building. Now let's try to understand that. This is your mains, okay, one phase and one neutral. Here PQR, Q and R. Cables for smoking alarm and three-way light switching. And R is the, okay, this is for cable for smoking alarm, Q1. So, and R is the circuit for outside GFCI protective receptors if they don't tap into living room, garage, bedroom or other such rooms. Never tap into that kitchen, dining, bath or laundry room circuits. Okay, now where the electricity is coming from, I just want to know. Maybe A point. A is the main service panel. Yeah, basically in your house you have we like we first bring the current in your main panel from the utility pole. There is your utility pole, right? And phase and neutral two wires, they coming, this is our utility pole, okay, and this is they coming in your room, right? So this is called main panel. From main panel to your main panel we call also main distribution panel, to your distribution panel. Okay, before we pass it to our distribution panel or distribution board, we add some circuit breakers with some protective devices as well as the energy meter. And from your distribution board, there we also add some devices like MCBs and RCCBs, and then we send it each circuits in a different room or in a different location. Okay, so this is the basic concept. Now let's try to understand here what they did. For example, let's not go into that, but how we feel. For example, like there is a one phase and one neutral is coming from outside. From outside means from your main panel, from your utility pole. Okay, utility pole, and from your utility pole it's come enter in your main panel. This is our main panel, and in your main panel we have main switch or changeover switch. Changeover switch, which is also connected with the changeover switch also have, there is, for example, sake of argument, there is also an inverter. So inverter and raw power all are connected, and there is a MCB, a big MCB, for example 40 amps of MCB is there, and this is connected to 40 amps MCB is connected. So we give a total, before we place, we calculated like this building have a maximum 30 amps of load will come. Now this main panel, we bring two wires to send it to the sub main panel or distribution panel, we call it. Like, because this is a small room, so we didn't distributed it in other locations. So from here we add another location, we add separated boxes there, and here we added different MCBs for different locations, and we send it like in your room for F location, then we have G location, then H location, then J location. Okay, and adding using a MCB, and then we send it to different locations. And you know what, there is actually different circuits we also run. For example, for lightning, right, we use inverter, UPS. So for example, you have a light means light plus fan. In light plus fan we use UPS power. UPS uninterrupted power supply, that is connected with nothing but your inverter and battery, battery or diesel generator, DG power. Okay, so that is will and then we use that UPS is also added with the changeover circuits for lightning power. For other power like AH power, we call it AH power or heavy power. For example, you have more than the devices that connected more than 200 watts. So your lights is 10 watts, right? Each, for example, 10 watts for LED, and for fan like 60 100 watts. Okay, now to more than 200 watts, for example, your AC, your geyser, your heater, or your washing machine, your micro oven, or your wash machine, or anything that you are using a heavy wattage, that's more than 200 watts, so we use this raw power. Okay, raw power directly we give it with a two module boxes. We give that power socket H. So for example, in your kitchen area, we provide that for exhauster fan or any other mixer, grinder, chopping machine, anything that you have in kitchen as well as in your utility room. So that is what it goes right from here itself. So same way, if we need another, for example, this is for one first floor. Now we have to go another floor. With the same, we will place another db and we'll connect from the db. We'll again distribute the wire from there also. So what we'll do first, we'll this wall for light purpose, this all the wire come first in a wall box, and then wall box to your light point. From wall box to your light point, if it is a automation, in case of automation, what we do, all the light points, because we do light and curtain motor point control, light control and curtain motor control, as well as the AC also we can control that using that. So for that, what we do, we send all the circuits in our main panel, and in main, and all the our switch box we connect it through KNX. Okay, we connect it through KNX, uh, KNX switches, and they connected in a another DB, that is automation DB. In the automation DB we have actuators, and will not go there, that automation is a different part. First learn the basics of electrical wiring. Now this is what the basics we as we understand. So this is how they run, but I will not go into that deep of the, like, then we have to also add a we talk about this ground, earth and all, right? So how to connect them. Yeah, there is another where one is phase, one neutral, another call is the ground or earthing. So that earthing is goes in the power sockets, that is green color where we use. Okay, now there is an inside the utility pole transformer. How you see this in utility pole, right? And this is how it's look like. Now let's try to understand. So this is a utility transformer, and this is a transformer, right? And a utility pole transformer have a this kind of coil, primary coil, that is because from the outside, like it is coming from your grid is nothing but the power substation. Power substation is connected to the grid, directly grid. They are generating a huge amount of power, right, using generator or turbine or nuclear power. So they send the high voltage like 500 kV, 500,000 volt. That is not required. We need how much? 240 volts, and they are sending us 500,000 volts. Now we need to step it down, right? So first they increase itself in the power grid. They step up the voltage, and they send it. And in the and we in our journey, in the journey, we try to step down it in a different ones, in a two steps. Like in a grid, first we step down into 7,500 volts in a substation, and then in your utility pole we step up into 240 or 120 using transformer, step up transformer, step down transformer. I hope now you get it. So transformer is used to increase the voltage as well as the decrease the voltage, okay, to control voltage. Okay, now this is the circuits, how this transformer work. For that you need to know more. This is secondary, primary is this one, secondary is this one. Now it's connected, and there is a central tap point, and to divide 120 volts. So total is 240 volts, and the central point tap is the 120 volts. Now you run it. Like for example, you need 240 volts, right? So what you will do, you tap any one electrical wire and one neutral wire, and it's become 240. So now there is nothing, those two are all are hot wire. You connect it here or here, you will get a 240. So now 120 for that central tap, we add we tap in the central tap. So what is neutral means? Now we need to know about this neutral, and I already told you Ohm's law and the basics of resistance and power and voltage, right? So okay, so resistance can also be a property of an uh, and an appliances that convert electrical energy to heat energy. We also use that resistance to produce the heat also. That is what we have lots of applications for heat. Now let's try to understand neutral means. The neutral conductor is the conductor that leads to back to the center tap to the utility transformer. It is connected to the earth at the two locations, the utility transformer and the main panel. That is why it is sometimes referred to as a ground neutral conductor. So its design is white tapped or black cable. In our case we use black as a neutral. Neutral current is the commonly referred to as the return current, return path, because the circuit once the current pass through the load, the white or insulated neutral conductor make the complete circuits back to the utility transformer, and all electrical current must take a complete loop. The current start at the utility transformer and must therefore return to the transformer, and the neutral is simply the return path of the loop. Yes, neutral is nothing but the return path. Okay. The neutral cable or the wire can kill you just as readily as hot cable. The same current that flow and hot conductor flow out at the neutral. If you place yourself in series within that loop, even on the neutral side, you will be electrified. Yes. For example, yeah, this is our hot wire, and this is our neutral our live or hot wire. You connected a devices called a light. Okay, you put it like this. So this will start glowing. Okay, now this is how series work, this is how parallel work. Okay, now you connected one phase neutral. Now what you do, one circuit, another circuit, this is what the series circuit. Yes, so later we'll discuss about that. So for now we'll learn this series and parallel, and never connect the series in a circuit. All the device must connect in a parallel. So thanks for listening, and